Okay, this is Mr. Peterson continuing the notes for Algebra 2, Section 1.5c, Graphing Systems of Inequalities. I'm going to start by correcting something I did at the previous page. I do want you on your homework to use pencil, guys. It's easy to mess up on these and are really hard to fix if you use a pen. Okay, so I mentioned that if you have the or equal to, you use a solid border. But if it doesn't include the or equal to, and I'll highlight two examples here, less than by itself, greater than by itself, then you use a dashed or a dotted line. And that indicates that the border itself is not part of the solution set. In other words, the points that are exactly on the line really don't work. Okay, so I have two of each of these, and what we're supposed to do in this exercise is just decide whether we'd be shading above or below, and whether we use a solid or dashed border. Now you can decide the dashed right away, solid and dashed. The first two examples here have greater than and neither one of them has the or equal to, so that's why you're using the dashed. The actual border has to be with the equal sign. Okay, the next two have or equal to, so that's when you use a solid border. Now, word of caution, okay? When you try and decide whether to shade above or below, you can't decide that until you've got the y by itself. So you first solve for y, and on this first example, I'm going to point out that this inequality that used to be a greater than sign turned around, and that happened because of dividing by -3 throughout. When you divide an inequality by a negative number, the inequality changes direction. So we might have thought that the greater than sign would make us shade above, but by the time you get down to the bottom, it's y is less than. So you'll shade below on this one. All right, let me write that in here. Shade below. So it'll be a dashed border, and we'd below that border. Okay, on the next one here, we don't have any place where we're dividing by a negative. You can see I divided everything by +2, and that means the inequality does not change direction. Y is greater than, the heights of the points are above the line. So we'd have a dashed line, and our shading would have to be above that line. Let me fix that a little bit. Above. That's what that's supposed to say. Okay, so the next thing we have over here is when we solve it, we're back to a case where the inequality changes direction. You can see that once I get down to this stage and I divide by -1, this inequality changes direction, and that ends up taking us to the final decision here where it says y is less than. We got to be below. Okay, and the last example here, if you solve for y, does not involve switching the sign. So dividing by 3, there's no change, and y is greater than is always associated with shading above the line. So that'd be a solid border shaded above. The other part C would be a solid border shaded below, and we've already done the other two. Okay, there is one exception to shading above and below. If you have a vertical line, a straight up and down line, okay, then it's impossible to shade above it and below it because it goes forever up, forever down. What you have to do is switch gears. The equations look a little different. You can see here's the x equals 2 line, and we have to be less than that. Well, x gets smaller if you go to the left. So x less than, this right here, that combination is associated with shading on the left. And you would hash it like this if you were using a pencil. Remember, don't use a pen. Okay. And the border is dashed because there's no or equal to in that inequality. So it just says less than. When it's greater than, you shade to the right. So you can see x is greater than. And so you want to be on the right side. And then you would hash it like this. And you can see my vertical line actually hits here at -3 and goes up and down there. Okay, so the only time you decide to go, instead of above and below, you go left or right, is when you're dealing with a vertical line, and you'll notice that you'll you only have an X and no Y. You only have an X and no Y. Okay, so we got a system of inequalities to graph here, and I'm just going to take you through the whole process. You're going to solve for Y, and you'll see me do that here. I took the like term, the 3x over the other side, and divided by +2. In the process, that does not change the inequality. They still point the same direction all the way through the problem. And when you get down to the bottom, you can make your decision. We're going to be shading above, greater than, and with the greater than by itself and no or equal to, we have to use a dash border. So we'll count out the y-intercept of 2 and a slope of 3 down and 2 over, 3 down, 2 over. And when you get this set up here, and you draw a line through there, a dashed line, the dashed line is an indication that you're actually not including that border itself. And what I'd like you to do on these is, after you get the first one done, put shade above that, just right above that. What that means is that ultimately all our shading has to be on that side. Okay? Just think of any point and go up, and you'll realize which side to go for above. Some people get confused. They think this is to the right, and it's actually to the right, but it's also above. And all you have to do again is put your pen on the line somewhere and go up, and you'll be above, so you know which side to shade. Okay, now I'm going to do the other one. And first of all, I'll write it down. Solve for y. And this one is not finished. I wanted to do it in front of you. This step, the next step, was divide by -4, which inverts the sign and makes it go the other direction. So when you get down here, you might have thought earlier with that greater than sign throughout most of the problem that you were going to shade above, but this less than sign, we want to be below. And this time we have the or equal to involved, so it's going to be a solid border. So I find the y-intercept of -3. You can see that right there. And I count out the slope of 1 up and 4 over, 1 up and 4 over, and then go the other direction. And draw a solid border this time. And that means those points on that line actually work, whereas the points on the other line do not work. And we have to stay below that line. So I'm going to put 4 dots here, a green one, and let's go with an orange one or a pink one, and then maybe a purple one, and a yellow one. And the dot that's below the solid line, those would be the pink and the yellow. And above the other one has to be that yellow region. So our solution set is over here in this area. There's millions of points that would work in here, and they're in that shaded region there. And once again, if you're using a pencil, you want to make these diagonal marks that are parallel to each other. Make it really neat, okay? Well, I'm not doing quite the best job here, but make it as neat as you can, okay? So that's the region, the solution region, millions of points that work, and I'm going to get rid of the ones that don't here. Those regions there don't work. And ladies and gentlemen, that's it for page 2 of the notes, and I'll pick this up again on the other side for page 3.